In computer science, a linker or link editor is a computer program that takes one or more object files generated by a compiler and combines them into a single executable file or object file. A simpler version that writes its output directly to memory is called the loader, though loading is typically considered a separate process. Overview: computer programs typically comprise several parts or modules. These parts modules need not all be contained within a single object file, and in such case refer to each other by means of symbols. Typically, an object file can contain three kinds of symbols: defined external symbols, which allow it to be called by other modules; undefined external symbols, which reference other modules where these symbols are defined; and local symbols, used internally within the object file to facilitate relocation. For most compilers, each object file is the result of compiling one input source code file. When a program comprises multiple object files, the linker combines these files into a unified executable program, resolving the symbols as it goes along. Linkers can take objects from a collection called a library. Some linkers do not include the whole library in the output. They only include its symbols that are referenced from other object files or libraries. Libraries exist for diverse purposes, and one or more system libraries are usually linked in by default. The linker also takes care of arranging the objects in a program's address space. This may involve relocating code that assumes a specific base address to another base. Since a compiler seldom knows where an object will reside, it often assumes a fixed base location. Relocating machine code may involve retargeting of absolute jumps, loads and stores. The executable output by the linker may need another relocation pass when it is finally loaded into memory. This pass is usually emitted on hardware offering virtual memory. Every program is put into its own address space, so there is no conflict even if all programs load at the same base address. This pass may also be emitted if the executable is a position-independent executable. On some Unix variants, such as Cintrana 3, the process performed by a linker was called loading. Additionally, in some operating systems the same program handles both the jobs of linking and loading a program. Dynamic linking. Many operating system environments allow dynamic linking, that is the postponing of the resolving of some undefined symbols until a program is run. That means that the executable code still contains undefined symbols, plus a list of objects or libraries that will provide definitions for these. Loading the program will load these objects' libraries as well, and perform a final linking. Dynamic linking needs no linker. This approach offers two advantages. Often used libraries need to be stored in only one location, not duplicated in every single binary. If a bug in a library function is corrected by replacing the library, all programs using it dynamically will benefit from the correction after restarting them. Programs that included this function by static linking would have to be relinked first. There are also disadvantages, known on the Windows platform as DLL hell. An incompatible updated library will break executables that depended on the behavior of the previous version of the library. A program, together with the libraries it uses, might be certified as a package, but not if components can be replaced. Relaxation. As the compiler has no information on the layout of objects in the final output, it cannot take advantage of shorter or more efficient instructions that place a requirement on the address of another object. For example, a jump instruction can reference an absolute address or an offset from the current location, and the offset could be expressed with different lengths depending on the distance to the target. By generating the most conservative instruction and adding relaxation hints, it is possible to substitute shorter or more efficient instructions during the final link. This step can be performed only after all input objects have been read and assigned temporary addresses. The linker relaxation pass subsequently reassigns addresses, which may in turn allow more relaxations to occur. In general, the substituted sequences are shorter, which allows this process to always converge on the best solution given a fixed order of objects. If this is not the case, relaxations can conflict, and the linker needs to weigh the advantages of either option. While instruction relaxation typically occurs at link time, Inner module relaxation can already take place as part of the optimization process at compile time. In some cases, relaxation can also occur at load time as part of the relocation process or combined with dynamic dead code elimination techniques. Linkage editor. In IBM mainframe environments such as OS/360, this type of program is known as a linkage editor. However, a linkage editor, as the name implies, had the additional capability of allowing the addition, replacement, and/or deletion of individual program sections. Operating systems such as OS/360 had a different format for executable load modules, in that they contained supplementary data about the component sections of a program, so that an individual program section could be replaced, and other parts of the program updated so that relocatable addresses and other such references could be corrected by the linkage editor, as part of the process. One advantage of this is that it would allow a program to be maintained without having to keep all of the intermediate object files, or without having to recompile program sections that hadn't changed. It also permitted program updates to be distributed in the form of small card decks, containing only the object module to be replaced. In such systems, object code was in the form and format of punched card decks, so that updates could be introduced into a system using the medium. In later releases of OS/360 and in subsequent systems, load modules contained additional data about versions of components modules, to create a traceable record of updates. Note: the term linkage editor should not be construed as implying that the program operated in a user interactive mode. It was strictly intended for batch mode execution. See also: Notes. References. External links: Ian Lance Taylor's Linkers blog entries, Linkers and Loaders, a Linux journal article by Sandeep Grover, another listing of where to get a complete collection of free tools for assembly language development.